Good afternoon, friends. So, in the yesterday's lecture, we have seen what is a general integration formula. Now, we will see what will happen if we put n equal to 1, 2, or 3 in the general integration formula. Here, we have to put n equal to 1, 2, 3, and so we can find out the trapezoidal rule, one third, and Simpson's 3/8 rule. So what we have to do in this trapezoidal rule, you put n equal to 1 and you have to find out the integration x naught to x1. If you put n equal to 1, so this suffix of x is 1. And then calculate this and you will get it is h by 2 1 y1 plus y naught. Similarly, you can find out for x1 to x2, that is h by 2 y1 plus y2. And up to the last term, we can find out the integration xn minus 1 to xn. Integration within the limit xn minus 1 to xn y dx is h by 2 yn plus yn minus 1. So combining all this, we can get the integration from x naught to xn, and that will be the formula is h by 2 y naught plus 2 y1 plus y2 plus yn minus 1 plus yn. Okay, two times. Now we have to find out the Simpson's one third rule. Put n equal to 2, that is wherever you are having n, put n is equal to 2. So here integration will be from x naught to x2. So 2h y naught plus delta y naught plus 1 by 6 delta square y naught. So after doing some calculations, if you take LCM of 6 outside and this 2h as it is, so we will get the formula is h by 3 y naught plus 4 y1 plus y2. Similarly, you can find out for next terms, that is x2 to x4, xn minus 2 to xn. In combining all those integration formula, you can get the result is first, what is the term outside, h by 3 plus y naught. Okay, well, first term is y naught plus 4 times all those terms which are having the coefficient is 4, and all the terms which multiplied by 2 will be taken in a second bracket, and the last term is y. Similarly, we can find out for Simpson's 3/8 rule. What we have to do in the Simpson's 3/8 rule, put n equal to 3. Wherever you are having n, put n equals to 3. If you put n equal to 3, it will be 3h y naught plus 3 by 2 delta y naught plus 3 into 3 by 3 into 2 minus 3 divided by 12 delta square y naught and so on. Okay. So after doing these calculations, we can get the result is 3h by 8 y naught plus 3 y1 plus 3 y2 plus y3. Okay. Similarly, you can carry forward this for x3 to x6, then the last term will be xn minus 3 to xn. And then combining all those, we can write the integration. Now we'll keep the terms which have which are multiple of 3, we will keep in one bracket, which are multiple of 2, we will keep in another bracket. And then we can write the formula, and this is a formula from Simpson's 3/8 rule. Now we will solve some examples. The one example we have already solved in the last lecture, and in this lecture we will solve one more example. So you can see here what is the example is integration 0 to 1 by 1 plus x dx. What we have to do is first we have to take h is equal to 0.5, and then you can calculate with the help of h is equal to 0.25. On the condition we have to, as already we are provided with h is 0.5, you can see the values of x are difference between every value of x is 0.5. Okay, here this is x naught, x1 and x2. So if we are having only up to x2, that is if n equal to 2, you have to use a formula with that n equal to 2. So first we will use a formula for Simpson's one third rule. In one third rule, put n equal to 2. Where you are having in Simpson's one third rule formula. So here we have a Simpson's one third rule formula that there they have to put n equal to 2. Okay. After putting n equal to 2, we can get the result. And similarly, we can have the n equal to 3, n equal to 2 in the Simpson's 3/8 rule. Okay, so here it is 3h by 3/8 rule. In the 3/8 rule, we have to do the same things. Okay, so here you can have, this is Simpson's one third rule, h by 3 y naught plus 4 y1 plus y2. After doing the calculation, it is 0.6944. You can calculate for our Simpson's 3/8 rule. Whatever the values we have, x naught, x1, x2, y naught, y1, y2. Use those values in the Simpson's 3/8 rule after putting n equal to 2. Where you have Simpson's 3/8 rule, so you can see here in this formula put n equal to 2. If you put n equals to 2, what we will get is this is y naught plus 3y1 plus 2y3. Not it is 2y with 3, no? y1 y2. And if you put n equal to 2, what will happen? Y naught 3y1 and plus y2, and hence finally you can get the result, and that you can calculate on your calc itself, and you can get the result is equals to, that is the answer of this will be, for 3/8 rule it is y naught plus 3y1 plus 3y2, and the answer is 0.8437. Okay, so in this way you can solve the examples. And the next we are going to see is numerical solutions of ordinary differential equation. To go with this method, what we have to do is, first we have one differential equation which is a function of x and y, and then what we have, we are provided with xn is equal to x naught plus n into h. Okay,